Hello, my name is Ashna Patel, and this is my Physics 2211 Lab 2 Motion of a Falling Object Lab Report. So a preview, essentially to start this lab, we were to understand Newton's second law, which states that in order for a velocity to change, there must be a net force acting on it. An object with a constant velocity means that there are no net forces acting on it, meaning that the net force is zero. In this lab, we are tracking the position of a falling object, and this indicates that there is a net force, implying the velocity will change. To move forward, we need to understand the position update formula, which is final velocity equals initial velocity plus F net divided by M times the change in time. We were also to understand the force of gravity and drag force as listed below. In this experiment, we were to record an object in motion at a constant speed without changing direction. Then analyze the recording using the Tracker app to find the object's observed position and corresponding time. From the data, we were to create an experimental model to reflect the movement of the object. After this, we used the starter code and edited it based on the observed data points in the Tracker app. We used the code to find the theoretical models using both gravity and drag. And finally, compare the results of the observed and predicted data. So here is my video in Tracker. As you can see, the system is the eraser and the surroundings are the wall and yardstick. This is the observed model. The initial conditions are the mass 0.01 kilograms and time 0.535 seconds, and average velocity, which is negative 0.989 meters per second. This is the GlowScript code with gravity included. As you can see, gravity is equal to 9.8. This is the theoretical model with gravity included. This was the graph based on data found in the observed model, and it takes into account the force of gravity acting on the object. This is the GlowScript code with both gravity and drag included. As you can see, B now includes the drag force, and FNet takes into account gravity and drag. And this is the theoretical model with gravity and drag based on previously found data points. Similar to the theoretical model with gravity, but it has a larger net force because it also takes into account drag force. This is a more accurate representation. In comparison, this is a chart that includes all models, Series 1 being the theoretical with only gravity added, Series 2 the theoretical with gravity and drag observed, and Series 3 is the observed in Tracker. There is very little discrepancy in the models. However, the model with the drag force is more consistent with the observed data points. That being said, in conclusion, the theoretical model that accounts for drag force is more consistent with the observed experimental model because there's less room for error when both forces are considered. Essentially, Newton's second law supports the findings in that the net force differs between the two models. A lower net force means lower velocity, and the object will fall slower than an object with only one force acting on it. So what does this mean? When comparing the two velocity versus time graphs, there's a curve that I observed in Tracker indicating that there is a final velocity, meaning an endpoint. The force of the drag and gravity are equal, meaning that the net force is zero. And what if? The terminal velocity would increase if the object was thrown downward, simply because the object would have a faster initial velocity because it was thrown. The drag force would thus be higher when there is a higher velocity. Thank you.